Hi there. Today I'm going to go through AQA's A-Level Maths Paper 3, just Part A because I don't really like statistics, and it's the June-November 2020 series. So question 1, we're given a definite integral and we're told that it has a value of 7, and we're asked to deduce the value of the same function but with 1 added to it. Now, if we think about what this integral represents in terms of area, if we've got a function f of x that looks something like that, let's say, then what that is telling us is that between x equals 0 and x equals 10, the area is 7. Now, if we add 1 to a function, what we do is that represents a vertical shift upwards by a unit of 1. So instead of, so basically the area is increased by this amount underneath here, which has a height of 1 and a width of 10. So we're adding on 1 times 10 to the area. So the answer is 17. Part 2, 6 cos theta plus 8 sin theta equals r cos theta plus alpha. So this is the general technique if you're adding together terms like this is to write it as cosine or sine and then use the compound angle formulae. Now you might just know the answer to this, but I'll just write it a bit more clearly. So if we use the double angle formula, then we've got r multiplied by cos, so cos theta cos alpha, and then minus r times sin theta sin alpha. And that's equal to 6 cos theta plus 8 sin theta. So if we compare terms, on both sides that involve cos theta, then we've got r cos alpha equals 6, and doing the same for sin theta, we get minus r sin alpha is equal to 8. And to eliminate the alpha terms, what we do is we square and add these. So we're going to get r squared into cos squared alpha plus sin squared alpha on the left, and then that's going to be equal to 6 squared plus 8 squared. The Pythagorean identity is that that bracket there is equal to 1, so we just got r squared is equal to 36 plus 64, that's 100, so r is 10. Okay, so the quick way to do this, of course, is just to add these together. So r squared is equal to 6 squared plus 8 squared. Determine which of these graphs does not represent y as a function of x. Okay, so the key word here is function. A function is a one-to-one relationship or a many-to-one. It cannot be one to many. And this graph over here is one-to-many. So if I take this value of x there and draw a vertical line up, you can see that it crosses the curve at more than 1 point. This is sometimes called the vertical line test. If this happens, if it crosses a vertical line crosses a graph at more than 1 point, it is not a function. So this is the one we're looking for. Okay, next we've got a polynomial, and we're asked to use the factor theorem. Now we're being told to use the factor theorem, so we can't use another method like polynomial long division straight away. But the factor theorem is that if x minus 6 is a factor, then that implies that the polynomial evaluated at x equals 6 is equal to 0. So that's just what we've got to determine. So if you work out 4 times 6 cubed minus 15 times 6 squared minus 48 times 6 minus 36, that is indeed equal to 0. So that's all you need to show. Prove that the graph of y equals p of x intersects the x-axis at exactly 1 point. Okay, now if we want to find other points, once we've found one factor, if we want to find other roots, then what we usually do is either do polynomial long division or compare coefficients. So I'll do a long division here. So I'm going to divide the polynomial by that factor. So polynomial long division, first of all, how many times does the highest degree term in the divisor go into the highest degree term in the polynomial that's left? And x goes into 4x cubed, it goes in 4x squared times. So then we multiply 4x squared by the divisor. So we get 4x cubed minus 24x squared. And then we subtract one from the other. And if we've done it correctly, the first term should always cancel. Second term, minus 15x squared minus 24x squared. So that's plus, that gives 9x squared there. And then we just repeat the process. So how many times does x go into 9x squared? It goes in 9x times. Oh, I should have brought the other terms down as well. So multiply that by the divisor, 9x squared minus 54x. And that gives us that. And then x into 6x goes 6 times. And what we see is that when we do that final step, we get 0 remainder. So that's just a bit of confirmation that what we did in part A was correct. Okay, if we got a remainder there, we've done something wrong at some stage. So the polynomial can now be written as that factor, x minus 6, times the quotient there, which was 4x squared plus 9x plus 6. Now, what we want to see is, does this factorize further? And the quickest thing to do is, first of all, to check if there's any solutions to that at all, which we can do by working out the discriminant. So discriminant b squared minus 4ac, where b is 9, a is 4, and c is 6 here. So we've got 9 squared minus 4 times 6. So that's 81 minus 96, which is minus 15, and that's negative. Okay, so therefore there are no real solutions. Okay, and therefore x equals 6 is the only root, the only solution, the only intersection point. And then the last bit is then state the coordinates of this point of intersection. Well, x equals 6 and y was 0, because it's where it intersects the x-axis. Okay, the next one is all about exponential decay. So this equation might look familiar to those of you doing A-level physics as well. So n is equal to n0 e to the minus kt. So k is some decay constant, n0 is the initial number of radioactive atoms, and n is the number after a time t has passed. And the t here is being measured in hours, and that's important. Must be careful to read the questions here. So first of all, it takes 15.9 hours for half of the sodium atoms to decay. So what that means is that when t is equal to 15.9, n is equal to a half of the original, so a half n0. So if we put all of that into the equation, we get a half n0 equals n0 e to the minus 15.9k. The n0s clearly cancel out. And then if we take logs and rearrange that, we get k is equal to natural logarithm of a half divided by minus 15.9. And that is approximately 0.0404359. The question is, though, determine the number of days required for at least 90% of the number of atoms in the original sample to decay. So the first step was to determine k, and now we can substitute another value back into the equation to find another value of t. So if 90% has decayed, then that means that 10% remain. So n is now 0.1 times the original amount. So substitute that in. And this time we're trying to find t, and we know k. So again, take natural logarithm and rearrange, we get ln 0.1 divided by minus k. And if we put that together, we get about 52.8 hours. But the question says determine the number of days. So if you divide that by 24, you get 2.2 days. Find the percentage of atoms remaining after the first week. Well, 1 week is 7 times 24, which is 168 hours. So T is equal to 168. We could just leave it in terms of N0, or we could say N0 is equal to 100%. Okay, so we start with 100%. So that N will then be a percentage. So 100 e to the minus, there's our K again, times 168. And if we calculate that, we get about 0.066%. Explain why the model can only provide an estimate. Well, the thing is here is that this equation, this exponential, it's a continuous function. So the answer you get will have some decimal value. However, the number of atoms is discrete. Okay, we can't, without going into the realms of particle physics, we can't have fractions of an atom. Okay, so it doesn't match up quite. So if it says you have 204.6 atoms remaining, well, that can't be the case. So we have to either round one way or the other there. Okay, 5D, explain why the model is invalid in the long run. Well, in the question, it said it was only valid for large values of n. Okay, so n is a decreasing function. So eventually, n is small. Okay, and then it's not valid anymore. Right, we've got graphs next, and it's various transformations applied, and you're asked to sketch the different graphs. So the first graph here is y equals f of x, and we've got 4 points indicated. And first of all, sketch the graph of y equals f of minus x. Well, what does this mean? Well, all it means is that we're mapping all the values, all the x coordinates are just getting mapped onto minus x. So we're not doing anything with the y values. So this point up here, 2 and 6, just becomes minus 2 and 6. So x has become minus x. The value that was on the y-axis, 0, becomes minus 0, which is still 0, so that doesn't change. The point down here, minus 1, gets mapped to 1, and then minus 2 gets mapped to 2. So it just flips it in the y-axis, reflects it in the y-axis. So it looks like that. 6b says we're doing this to the function. So what does this mean? Well, f of x was our original y, so we're taking the y values now and we're just mapping them onto twice y and then minus 4. So we're just doubling all the y values and then subtracting 4 from them. So the upper point that was 2 and 6, that's now going to be 2 times 6 minus 4, so it's 12 minus 4 is 8. So this point up here becomes 2 and 8. Okay, so I'll just put that calculation on so you can see how I've done. So it's 2 times 6 minus 4. 12 minus 4, 8. And we do that with all the other points. So the one that was on the axis, the y value was 2. So 2 times 2 minus 4 is 0. So that point is now at the origin. The point minus 1 and 0, So the 0 becomes 0 minus 4, which is minus 4. So this point is now at minus 1 and minus 4. And then the other point, minus 2 and minus 2, the y value becomes minus 4 is minus 8. So this is minus 2. So the x values don't change, but the y values do. So that's minus 8. So the graph now looks like that. Last part, what does the derivative look like? So for the two horizontal parts of the graph, then that just means that it's the gradient is 0. So between less than minus 2 and greater than x equals 2, then it should just be a horizontal line along the axis. In between, it has a constant value, but what is that value? Well, we know that m is equal to delta y over delta x. That's the easiest way to work the gradient of a straight line. So it's 6 minus minus 2, the change in y values from there to there. And then the change in the x values is 2 minus minus 2. So that's 8 over 4, which is 2. So the gradient between those points is 2. So we'll just label that on there. And that's it. You could put maybe a dashed line up there just to guide the eyes. Okay, next one. We've got these binomial coefficients now, n choose r, and these can be written in terms of factorials. Now remember what a factorial is. It's n factorial means we multiply all the integers together from n down to 1. So that's the bit of knowledge that we need for this question. So nc2, that means n factorial divided by 2 factorial divided by n minus 2 factorial. So n factorial is n times the integer 1 less, times the integer 2 less, 3 less, and so on, all the way down to 1. 2 factorial is just 2 times 1. And then n minus 2 factorial is n minus 2, n minus 3, so on, all the way down to 1. And what we can see is that all of these values from n minus 2 down disappear. They cancel out, and all we're left with is a 2 on the bottom and then n minus 1 on top, which is what we were asked to demonstrate. Part B, show that this equation involving these coefficients reduces to this quadratic. So where do we get started there? So let's just write these in terms of the factorial form. So n choose 4 is going to be written as n factorial divided by 4 factorial, then n minus 4 factorial. And n choose 2 is going to be written like so. Then if we move all of the, let's say we move all the constants to the right hand side, so we get 51 times 4 factorial divided by 2 times 2 factorial, and then move all the n terms to the left. Well, first of all, we can see that n factorial cancels out straight away, and we're going to get n minus 2 factorial divided by n minus 4 factorial. Now, in the same way that we cancelled things out before, the only two terms that are going to remain on the left-hand side are going to be n minus 2 and n minus 3. All the other terms from n minus 4 onwards down to 1 will cancel above and below. And the rest of this, we've got 4 factorial, which is 24, divided by 4 on the bottom is 6. 6 times 51 is 306. So if we multiply everything out, we get n squared minus 5n plus 6 equals 306. And then if we move that constant across to the left, we get what we wanted. And hence solve the equation. So just solving that quadratic, so I'll just write that down again here. So we just need to solve this, and by inspection we can see that two factors that multiply to give minus 300 and add to give minus 5, n to give minus 5 are minus 20 and plus 15. So either n is 20 or n is minus 15, but we know that n has to be greater than 0, so n equals 20 is the only solution. Right, geometric series now. So we're told some information here. We're told the sum to infinity of a geometric series is 96. And we know the formula for a sum to infinity is the first term a divided by 1 minus the common ratio r. So we can use the information in the question just to write that. The value of the sum to infinity is 96. We also know the second term of the series is 18. So the nth term in a geometric series is the first term times r to the power of n minus 1. So the second term, u2, which has a value of 18, is equal to a times r to the power of 2 minus 1, which is just 1. So we get 18 equals ar. Now if we rearrange this for a, we get a is equal to 18 over r, and then we can substitute that back into the other equation. So we get 96 is equal to 18 over r, so I'll put that in the denominator, times 1 minus r. Let's bring the r times 1 minus r to the left hand side. So we get 96 r 1 minus r equals 18. So we get 96 r minus 96 r squared minus 18 equals 0. I'll multiply by minus 1 and write it in the usual order. And then it's just a case of factorizing this. Now we could use the quadratic equation here, but let's see if we can factorize it. So there's a common factor of 6. So let's divide everything by 6. So we get 16r squared minus 16r plus 3 equals 0. And then if we have 4r in each bracket and minus 3 minus 1, then that works, doesn't it? So minus 3 times 4r is minus 12r, and then minus another 4r is minus 16. Yeah, that works. So r is equal to 3 over 4, or r is equal to 1 over 4. And substituting each of these values back into the equation for a gives us a is equal to 18. So it'll be 18 times 4 over 3, which is 24, or 18 times 4, which is 72. Okay, so we've got two pairs of values. Now, let's use the second statement. The first term of the series, so that's a, is less than 30. Okay, so it must be this pair because a is less than 30. So the first term is 24 and the common ratio is 3/4. Okay, let's say this next one then, show that the nth term can be written like this. So we're going to substitute in those values we just found. So we had again that the nth term is a r to the n minus 1. So the first term was 24, r was 3/4. So we can write that. Now, let's use the question as a guide. It wants us to express this as powers of 3 and powers of 2. So what we should do here then is we should express what we've got in powers of 3 and 2 where possible. So 24 is equal to 8 times 3, which is 2 cubed times 3. So we'll put that in first. So 2 cubed times 3. 4 in the denominator, in the bracket there, is 2 squared. So we'll substitute that in as well. Then let's just use our knowledge of indices to expand all of this. So we've got 2 cubed and a 3 outside. We've got and then another 3 to the power of n minus 1. And then we've got 2 squared in the denominator, so that's 2 to the power of minus 2 to the power of n minus 1. So that's going to be 2. So minus 2 times n to the minus 1 is minus 2n plus 2. Then combine the terms that have the same base. So we're going to get 3 plus minus 2n plus 2. So that's going to be 5 minus 2n. And 3, I've got 3 to the power of 1. Let's just put the 1 in to be clear. Times 3 to the n minus 1. So the 1's cancel and we're just left with 3 to the n. So we're almost there. All that we have to do is rewrite this as 3n divided by, and if we put it back in the denominator, the power becomes negative, so it's minus 5 minus 2n, which is the same as 2 to the power of 2n minus 5. And then part 2, hence show that you get this expression in terms of logarithms. So let's just take logs of the whole expression. So log base 3 of the nth term is equal to log base 3 of all of this. If we've got a logarithm of a ratio, we can write that as the difference of the logs. So we can write this as log base 3 of 3 to the n minus log base 3 of 2 to the 2n minus 5. Then we can bring coefficients to the front, powers down to the front as coefficients. So n log base 3 of 3 minus 2n minus 5 log base 3 of 2. And then we'll expand that. Well, also log base 3 of 3 is just 1. So the first term is just n. And then if we expand the bracket, we've got minus 2n times log base 3 of 2. And then minus 5, so that's plus 5 log base 3 of 2. And then all that we have to do in the last step then is just factorize the n in those first two terms. Take that out as a factor. And then we've got what we needed. Okay, now just a little bit of trigonometry. So for cos theta not equal to 0, prove this identity. Okay, so first of all, it's often useful to rewrite things in terms of the more familiar sines and cosines. And what you should usually do when solving when proving identity is start with the more complicated side and go to the simpler side. So I would start with the left-hand side here because that's more complicated. So cosec, well, I know that cosec is 1 over sine, so I'll write 1 over sine 2 theta first of all. And cot 2 theta, well, that's cos over sine. And, oh, well, that's good because I seem to have a common denominator between those two terms. So let's just put them both over sine 2 theta. Okay, and then from there, where can I go? Well, I know that cos 2 theta is equal to, and there are various ways of writing this, but one way that's going to be useful to us is going to write 2 cos squared theta minus 1. Okay, we'll use that form because the ones will cancel on top. So we're going to get 1 plus 2 cos squared theta minus 1 divided by sine 2 theta. The 1's cancel. Oh, sorry, what I'll also do is instead of writing sine 2 theta there, I'll use the double angle formula for sine as well. So it's 2 sine theta cos theta. So let's do some simplifying. So the 1's cancel, then the 2's cancel, and then 1 cosine cancels top and bottom. So I'm just left with cos theta over sine theta, which is cot theta. So that would be proof finished. Then 9b, explain why they're not equal if cos theta equals 0. Well, just go back to that first step up there. We wrote the terms on the right hand side, so that the left hand side is fine. The left hand side is cos theta over sine theta. So there's no problem with that. There's no problem with that if cos theta is equal to 0. But these terms on the left, once they have sine 2 theta on the bottom, so the first term was 1 over 2 sine theta cos theta. The second term also had that on the bottom. And in this case, we'd be dividing by cos theta, dividing by 0. So that's not defined at cos theta equals 0. Okay, so the problem is basically that the right hand side is not defined for cos theta equals 0. Okay, and that is it. I'm not doing the statistics because I really don't like it. So if you enjoyed this video and you found it useful, please like and subscribe. And if you want some additional support, then please visit my website, www.physicsmathstuition.com. Okay, bye for now.